Hello, in this video, we're going to be going over functions. But first, to do that, we need to understand what a relation is. A relation is a collection of ordered pairs which connect elements from the domain, which are the inputs, to the range, which are the outputs. The domain is often known as the x-values in a function or relation, and the range is going to be the y-values. Relations can be shown in many ways, like a set of ordered pairs, a graph, or a table. Now, let's go over the first one to see if we can identify the domain and range. So, the domain is going to be the x-values. The domain for this is going to be 1, 3, 5, and 7. So basically, what are you putting into the relation to get your output? And the range, aka your output, is going to be the resulting number. The range is going to be 2, 4, 6, 8. Now, let's discuss functions. A function is a special kind of relation where each input in the domain, the x-values, maps to exactly one output in the range, the y-value. What's important to know about functions is that repeated y-values are okay, but repeated x-values are not. And the reasoning for that is because if you have a repeated x-value, it means that you have the exact same input, but you have multiple outputs. Now, let's go over some examples. This is an example of a function regarding the student and their eye color. So the student is going to be our input, aka our x, and the eye color is our y. So this can be rewritten as f student equals eye color, because we have to put in the student to get their eye color, right? So f of Anna equals blue, f of Bree equals green, f of Carl equals blue. We know this is a function because every time you put in Anna, you'll get blue. You'll get the exact same eye color. So that means that one single input has one single output. Now, let's go over to another function, the number of days in a month. Like before, our month is our x, and our number of days is going to be our y. So our function can be written f month equals number of days. And we know that this is a function because every time you put in a month, you'll get one exact answer for number of days, right? Like January will always have 31 days, April will always have 30 days, and that will not change. Now, as we stated before, repeated y values are okay, but repeated x values are not. And as you can see here, 31 is repeated and 30 is also repeated. But the idea is that April is always going to have 30 days, so it's still a function, even though that another value also makes it have 30 days. We've gone over how to check whether a relation is a function based on checking for repeated inputs for ordered pairs and a table. But there's actually a different way to check whether a relation is a function based on a graph, and that's the vertical line test. The idea for the vertical line test is that a set of points is a function if every vertical line intersects the graph in at most one point. What does this mean? This means that you should be able to draw vertical lines at any point in the graph and check how many times it intersects with the graph. In this case, it only intersects once everywhere, so we know that this is in fact a function. And what about this one right here? This relation has more than one intersection, so we know that it is not a function. And what about this one right here? Yep, it only intersects in one point, so this one is also a function. What's important to realize is for the vertical line test, one vertical line having more than one intersection is all you need to consider something not a function. If every line is good and only intersects at one time, then it is in fact a function. Now, let's do some practice. We're going to find out whether each of these three relations is a function. So let's start with the first one. We have a table with x, y with the points 1, 1, 2, 7, 4, 3, and 5, 8. Is this a function? Yes, it is a function. Why? Because there's no repeated inputs. Which means that each input only has one output. 1 is always mapping to 1, 2 is always mapping to 7, 4 is always mapping to 3, and 5 is always mapping to 8. Now, what about this set of order points? 1, 2, 2, 3, 4, 5, and 1, 5. Is it a function? No, it's not a function. And the reasoning is because we have a repeated input. As you can see here, 1, 2, and 1, 5. 1 cannot map to both 2 and 5, so it's not a function. And what about this relation right here? Is it a function? No, it's not a function. Because it's a graph, we can use the vertical line test. So if we draw a vertical line, say here, it hits it at 2 points. So, does not pass vertical line test. Now, let's go over what function notation is. Function notation is a way to express a function using f of x instead of y. F of x is pronounced f of x and not f multiplied by x. So an example is that y equals 3x plus 5 can be rewritten as f of x equals 3x plus 5. So function notation, as an example, that we used before, is f of x equals 3x plus 5. I just want to break down the different parts of this. So the f of x is considered the name of the function. The x is considered the input, aka the domain, and 3x plus 5 is considered the output or range. And this output would be considered this entire 3x plus 5. So function notation can often be used to try to find the y value based on the x value. So an example of how function notation might be used would be something like f of 3. And then we're trying to find what f of 3 is. And what this means is we're plugging in 3 for the value of x. So we know this should be 3 times 3 plus 5 equals 9 plus 5, which is 14. So we know that f of 3 is equal to 14. Let's do another example. We can also do f of, let's say, 1. F of 1 means we're plugging in 1 for x. We get 3 times 1 plus 5. This gets us 8. Another way to write this would just be the ordered pair 3, 14, and the ordered pair 1, 8. So overall, function notation is just a different way of writing a function. Now, let's do some practice for function notation. Our question is, if f of x equals 2x plus 3, find f of 4. Now, what does f of 4 mean? F of 4 means that x is going to be equal to 4 in this case. So we plug in 4 for x. So f of 4 is equal to 2 times 4 plus 3. This gives us 8 plus 3, which is 11. So f of 4 is equal to 11. And like we discussed before, the ordered pair for this would be 4, 11. Now, let's do this question. We instead have this function written as x and f of x. So as you know, f of x is basically just y, so these are all just ordered pairs. Our question is to find f of 5. Now, what does f of 5 mean? It means we're looking for the value of y when x equals 5. The value when x equals 5 is going to be 8. So f of 5 equals 8. What about f of 7? This is going to be the y value when x equals 7. That would be 9. We get f of 7 equals 9. So when you're given a table like this, and you're trying to find f of something, you just read the table. And that's the end of today's video. Thank you so much for watching.